Well, to be perfectly honest, the first two videos on the skid steer have not gone very well. They both involved taking apart an engine that ended up being bad. The first engine was bad because of a poor design decision by Perkins, and the second engine was bad because they decided to run it with no air filter. However, I'm going to try to turn things around in this video. The goal is to completely rebuild the Yanmar engine that I got as a replacement. This is the Yanmar 4TNE98, which is the indirect injection version of the 4TNV98. It's a very similar engine, also very similar to the 4TNV94. So the engine block's currently at the machine shop, but let's talk about parts really quickly. My personal preference when doing something like this is to just order everything through a distributor. Otherwise, you end up piecing stuff together on Amazon or eBay, and it ends up just being junk that you don't know where it's from. I mean, I've been burned by that on this channel several times. And when you go through a distributor, you can give them like your engine serial number, and they can make sure you have the right part and it's not from a questionable source. So fortunately for me, I had already been in talks with Area Diesel to get my injectors and pump rebuilt. And they mentioned that they were a distributor for Maxiforce, which was great. That's a good aftermarket brand. So I went ahead and ordered all my parts from them. They just arrived. Let's go take a look at them. So this engine doesn't have sleeves in it, and the bores were all completely worn out due to it being dusted, so you have to have it lined. And these are semi-finished. Okay, so we'll set this aside for the machine shop. Are the other ones in here? So next up we have rear main, front seal. These are the small end rod bushings. We're going to need that for the machine shop. Bearings, connecting rod bearings, camshaft bushing. Now on this Yanmar, there's only one camshaft bearing. This is it. That's getting replaced, so that goes to the machine shop. Intake valve. There's just one in here, two in here. So these are the other two intake valves. Now, I talked to my machinist about this ahead of time, and he said because the engine was dusted or run with no air filter, he's almost assuredly you're going to need new intake valves and new valve guides. So, oh, yep. So this says valve exhaust, but it's the same part number for intake and exhaust. So he's going to need these. Now, lifters. I got new lifters. I'll show you why real quick. So the old lifters had a decent wear pattern, but there's just clearly a lot of dirt that had kind of gotten ground into them. It's not, I mean, these probably would have been okay, but lifters aren't really that expensive. Oh, those are just the main bearings. Don't need those yet. New thermostat. Pistons. Is there 5 of them? Oh, new oil pump. A new oil pump is kind of just a really good idea. Yep, that's the right one. Great. Wrist pin in here. Okay, we got rings, good. We're gonna need a wrist pin so the machinist can remount the small end bushings to the right size on the rod. I'm gonna quickly measure all 4 of these to make sure they're all the same. I've been burned by that before. Let's take a look, let's compare this to the old one, make sure it's right. That looks the right size. Yep, that's the same amount of cutout about. Yeah, the ring height is the same. I think right there is good. Wrist pin outside diameter 1.1806 to 1.1811. So we're perfectly within spec. Yeah. Pretty much dead on. Yep, exactly the same. Great. Other box. These just another liner, and this is the gasket kit. Now, I'm hoping there's actually gaskets in here because the original OEM manual, they say to use gasket maker for everything, which, you know, RTV. So Maxiforce, good brand. There are a bunch of Chinese knockoffs. I didn't realize this. You can go on like AliExpress or whatever those websites, and you can order an entire counterfeit Yanmar engine off of there for like $4 grand delivered. Like the engine block, everything is completely counterfeit. I'm tempted to actually buy one just to see what it's like, but okay, yeah. So no gaskets. So we're going to be using RTV unless I can source. There's 2 front cover gaskets. There's the oil pan gasket. There's basically those 3. We don't have anything. And we are gonna need anything out of here? Valve seals, maybe? Are they in here? Usually they put valve seals. Oh, yeah. Take those to the machine shop. All right, a couple other things I ordered myself. When Area Diesel was looking for this stuff, they were out of stock on the aftermarket water pump. So they only had OEM, which is $450. It's just not worth it. So this is a one I ordered. It's the correct one though. I think I got it for like 90 bucks. I forgot about this, but I needed a new cam plug. This is a one-time use thing, and I hit the old one out. So I do need to bring the rods to the machine shop. So the total cost of all the engine parts ended up being about 1,200 bucks. Now I'll get into all the details of this later, but I did mention in the previous video that I had worked out a deal with the person that sold the engine to me to kind of recoup some of these costs, because it was sold to me as a good running engine, and it definitely was not. So let me just say I did end up recouping a lot of the costs. He ended up being a good stand-up guy, didn't have to threaten him or anything like that. I'll cover the final cost later in this video, as well as I got a little bit more information out of him as far as where this engine came from and why it was sold as a good running unit. Okay, I got everything back from the machine shop here, so if you'll indulge me just for a second, I'd like to go over what I had him do, why, and how much it costs. All right, so the first thing on the list is obviously having the block and the head cleaned. It was just run through the jet wash and scrubbed out. It wasn't hot tanked. And this actually works pretty well for me because, one, it leaves a soap residue all over everything, and I found that bare metal won't rust. I'm gonna do one final cleaning before I assemble it, so you'll see that in this video. That was $140. Next up is having the block bored and sleeved. I've never had to do this to an engine before, but you can't even see, you have to really look close to see the sleeve in here. I mean, you can, yeah, I guess you can kind of just barely see the line there. So he definitely, you know, bored it, put the sleeves in, and then decked it after, which would make sense. The one place where you can tell it's been sleeved is at the very bottom. So you can tell they bored down to about here and then press the sleeves in, and then this, maybe the bottom, I don't know, 1/4 inch is original cylinder wall material. So boring the block he has is $200 and sleeving it was $400. I also had him finish hone the cylinders, which I think he just included that in the sleeving price. So the next thing I requested, and this was when I was taking the engine apart, I noticed that a couple of the mains came out a little bit too easy in my opinion. So there's a fix for that. You can have them peened back and then you have to re-line hone the whole thing. So he did that, and I'm gonna take one of these off. I think it was either the front or the back came off really easily. Let's see if it's improved. Oh yeah, that's a lot better. Much better fit. Okay. So the cost to have that fixed and line honed was $200. Next we have decking the block, which is pretty obvious. That was $100. What else for the block? Oh, new front cam bearing. We got to check that, make sure that the cam fits in there. This block, and apparently this is pretty common, I wasn't aware of this, but on a lot of these tractor engines, there's only one cam bearing in the front and then the other two are just hard in the block. I've measured all those already and those, everything's good, but I haven't checked this front cam bearing. Let's check that real quick. So I did measure this diameter, but let's just double check it with the cam. The journals on this cam, the front and the back are supposed to be the same diameter, but the middle one is a little bit smaller. So if I check the back on here and it fits, we should be fine for the front. Yep, I think we're good there. Of course, we want to make sure that he lined this up right, so that one looks good. Let's check the other one. That one also looks great. So the price to take out the old bearing and put a new one was $40. So next up on the head, we had surface it. So this has all been smoothed out. That's all soap residue there, that mess, but this has been smoothed out. So it was $100 to surface the head. And on the valves, we replaced the intake valves and the intake valve guides. And this was because it was a dusted engine. So it's extremely common that the valve guides go bad. And sure enough, they were. The intake valves themselves actually weren't that bad, but the guides were. Replacing the valves and the guides was $60. And then doing a valve grind, $245, and pressure checking and all that stuff. So it was just about $400 to do the head, which is almost always what he charges to recondition a head, a 4-cylinder head at least. Last thing is the rods. So when I was taking the engine apart, I noticed that the rod bearings fell out way easily, which is usually a sign that the rods need some help. So I had these honed and cleaned up, and he actually mentioned that they definitely needed it. They were not in the best shape. So it looks like he did a pretty good job. They looked really nice. Then obviously on the small end, replaced this bushing. I measured all the pins before I went in, but he fitted it to the pin I gave him. So these should all be fit perfectly. Yep. So a pin fit was $80 for all 4 rods, and the reconditioning this side is $120. So the grand total for all machining, including environmental fee, whatever that is, don't have sales tax here, was $1,752.40. Which he had quoted this to me before I had him start any work on the block, and I had passed that information on to the guy I bought the engine from, and he refunded me that money. I almost forgot the crankshaft. So I took the crankshaft to a different shop than I've ever been to because I thought that one journal was going to have to be ground. I think it's the only place in town that still actually grinds cranks down. Everyone else is closed down, or they just send it to that place. They said they were just able to polish it and that it didn't need a grind. So they have everything marked as standard for mains and rods. They did a very good job of polishing this. I also had them polish this, and I think this is going to be good enough. I don't have to put a speedy sleeve on here. So the cost for this was either $125 or $150. Pretty reasonable, and they did it like in about 2 hours. So while I was waiting for that, off camera, I cleaned a lot of stuff. Pretty much everything's clean over here, or it's initially cleaned. It's still going to get a final cleaning. We got the intake and exhaust and other random stuff over there. There's a few things on this engine that I found that I'm not used to. Number one is the head bolts and the rod bolts are not torque to yield. You can reuse them according to the manual. The rod bolts are only torqued to like 40 foot-pounds or 50 foot-pounds, like hardly at all. The heads, I think, are 80 or 100. They're not torqued very much. I did go through and measure all these though, make sure they're not stretched out at all, and these were all good. The other thing that I actually don't like about this engine, I think I mentioned it in the last video, is they don't use gaskets on like the timing cover to the engine and between these two and the oil pan. They just use RTV. That's what the manual says. That's what was on there originally. I don't think you'd want to put a gasket on because the spacing is all set up for RTV. Cleaning these took forever, getting all the RTV off, getting it out of all the bolt holes and the threads. It was everywhere. I did manage to find an aftermarket gasket for the oil pan, so I'm excited about that, not having to use RTV. All right, well, that was a lot of talking. Let's get to test fitting. Oh yeah, these are way more snug than they were. So much better. These actually have the Yanmar part number on them that says standard, and it's the part numbers right above them. The bearings that I pulled out did not have that, so seems like someone may have rolled some in at some point. They're really catching on this hone job here. There we go. Looking up the spec here, this you got to be careful on the spec sheet because this is both for the 4TN V and E for some of these specs, and they're different, but it's the same for the main bearing journal. Oil clearance 1.5 to 2.7 thou, and holy cow, the limit's 5.9. That's open. All right, well, we'll start out with the green plastic gauge, and this is for 1 to 3 thou. So If we're lucky, we'll be in this range for all of them. Easy. Oh boy, I can't get my hand in there. Journals on the crank already have some lube on them, so I'm not gonna, as long as the plastic gauge doesn't get knocked off here, we should be okay. Okay. Is this the front? I do have a plastic gauge on the top here. And so these are torqued to 80, which I looked up, the head bolts are also torqued to 80. It's the same bolt size, or at least diameter. And I double checked the rods. Those are only torqued to 40 foot-pounds. All right. Rub the plastic gauge off. It's coming off pretty good. No, don't drop it. Oh, there we go. Come on, easy. Okay, I got my little gauge here. So we want it between, I think 1.5 was on the minimum side. So hopefully less than 3. Plastic gauge, you know, really not super accurate. I think it usually errs to it's bigger than you think. Like there's more clearance than you think. Maybe that's better. Yeah, so we're right at 1.5. So it's probably a little bit over 1.5, but that's still really, really good. That's like on the low end of the spec, which is fine. So we should have pretty good oil pressure there. Go with the next one. Fat fingers out of the... Make sure it's actually touching. Yeah, so it's a little bit less smashed than 1.5, which means it's bigger than 1.5 by a tiny bit, obviously. So let's check the other side. There we go. So, yeah. Okay, well, everything came back between 1.5 and 2, so let's do the rods. And, oh, he torqued those, so I guess that would make sense. By the way, I stamped these rods. There's like a 1 and a 1 here. It doesn't really matter since the block got sleeved and the new pistons and all that, but I'll put them back in the same location, so if this engine ever gets taken apart again, and you'll know what came out of where. This table is clean, by the way. It just looks like it's got stains all over it. I ran out of the green stuff, so we'll be using this, which is 0.2 to 0.6. So as long as hopefully we'll be fatter than 0.2, but we won't know if we're under. It should be fine though, since really all we're checking here is that the crank journals weren't overground and the rods weren't over honed. 1, 2, 3, 4, 5, 6, we got 1, 3. I just dabbed a little bit of oil on there and that seems to hold it. So we can do it sideways now. Feel like there's a high likelihood of something going wrong if all 4 of these are on, so we're just going to do one rod at a time. We'll torque it and take it right off. I don't really want it rotating on here. Okay. Okay, nice and easy. Let's see what we got here. So we got kind of cockeyed. So it's tighter than 0.3. Yeah, it's right around 2 thou. On the other side, most of it came off. the onto the rod cap here. Yeah, this is about the same. All right, well, they all look pretty much the same. Let's see if I can do this without dropping the crank. So we're looking at the red there. All pretty much the same around the 2 thou or tighter. And there's there. They're all the same. You know, as you already know, plastic gauge is not super accurate. You can't really build an engine with it, but it's just for a sanity check, make sure everything's close. So I'm happy with that. Time for the individually wrapped, huh? Oh, it tells you which is which. Look at that. I'm used to these being like razor sharp on this corner, but they've been cleaned up a little bit. That's nice. It's a fair bit less gap than that was in there originally, that's for sure. The manual only has 4TNV98, it doesn't have a 4TNE98 spec, but we'll just go off this for now. Top ring end gap is, and I got a millimeter gauge here, so 0.25 to 0.45 millimeters. Here's 0.45. That's way too big. Here's 0.25. Oh, that fits. It's 0.3. 0.3 barely fits in there. So that looks good. I'm going to check more in this bore in a little bit, but I like to take the same ring and do all four just so I can get an idea of how all the cylinders are with respect to each other. Especially since it's been sleeved, I have no idea what to expect. So that one's a little bit more open. It's about the same as cylinder number 2. And that one's pretty loose comparatively. So I'm going to put all 4 rings, all 4 top rings in number 1 now, so I can get an idea. If there's any variation between the rings, now I can kind of space them out. So that one's a little bit looser. 0.4 fits in. 0.45 does not fit in. Okay, so what I had written down here was cylinder 1 had a 0.3 gap, 2 had a little bit, 2 and 3 both had a little bit more than 0.3 with the same ring, and then 4 had the 0.35, so 4 was the most open. So on the rings here, the smallest ring was this one, which had like a 0.35 gap, so this is going on number 4. The biggest ring, which had a 0.4 plus gap, is going on number 1, and then these two, which are about the same, kind of in the middle, go in cylinders 2 and 3. This is complete overkill, by the way. I'm just just trying to make everything even. All right, I'm gonna do the same thing with the second ring. I'll just measure them all on here. And the spec for the second ring is 0.45 to 0.65, so they're supposed to be a little bit more open, which it looks like it is. That's a tight 0.45 right there. Yeah, this is right at 0.45 as well. So second rings are all exactly the same. So the rings are all picked out. This is the number 1 ring. So next step is to check for cylinder taper and roundness. So for taper, all we're gonna do is we're gonna put this ring back in and measure it in a few spots all the way down the bore. It should be about the same gap all the way down. And to check for roundness, I'll take a flashlight and shine up from behind, and hopefully I see no light coming around anywhere. Okay. Looks pretty good there. You just see the gap. So this is about halfway down. Right there. So it was 0.45 at the top. Yep, that's exactly the same there. Same amount of drag. Okay, no light coming through. By the way, I forgot to mention, I've been kind of wiping these cylinders down a little bit with some light oil, just so nothing scratches. It's probably good right there. I mean, it still drags, just not quite as much. So maybe it's a little bit more open, but not, that wouldn't be a problem. Looks good. Okay, so 2 was perfectly straight, and then there was a very, very slight taper, like point. I mean, just you could just barely tell that it changed on 3 and 4. The overall, very good. Let's get this last ring out of here. So I already chased all the threads on the outside of the block. You can see there, just to get mostly the dirt dauber nests out, and I'm going to be using all these mounting holes probably. I still want to chase the threads on the head bolt holes though. So, and they're actually kind of a weird size. It's, what is it, M11 by 125. Not something I come across much, but I did get this tap. These things are really expensive, by the way. This is a thread chaser. It's not a cutting tap. I want to do the cleaning as fast as possible because the faster you do it, the less it's going to rust. Kind of go through this and find out which brushes I want to use and have them ready to go. This is the main oil galley. I got these 2. This one might be too big. Let's see. Where does that go? That goes somewhere. A lot of dirt came out with that. Yeah, I see it going through. Okay, those go into the cam bearing, so we'll get those. And then these all go into the main oil galley. Is that it? There's not much to this thing. It's pretty simple. It goes through this hole too. So I think the last thing is the oil supply to the head, which it looks like it goes through the other cam bearing hole in the front. I'm just going to be using Dawn for this in one of these little foamers. These are like 10 or 20 bucks on Amazon. And pardon the mess here, but here's my outdoor spigot. It's on the inside, but I use it for outside. And it's got a hot cold running to it, so I'm going to run it with full hot, which will help. So it's about 25 degrees out here, which I think is actually going to help because it's so dry that I think it'll help prevent rust. Just a little bit cold. This is where it kind of pays to do a dry run. This one was full. I remember this one being full of like just sludge. And I see some coming out, so this is going to take a couple rinses. Can't see the holes in the, there we go. So that one's got some dirt in it. Yeah, we're gonna need to do a couple rinses on this, I can already tell. Just based on the dirt that's coming out of it. get some. This is gonna rust super fast. Once again, very dusty environment here. All right. Did it rust? I don't see any rust. Must have done it right. Okay, these are lint-free rags, but you got to be a little bit careful with them because this cross-hatching is so rough that it can chew the rags up. In fact, I might need to switch over to a, yeah. There we go. Get all this plastic gauge off here. This thing is pretty clean already. I guess they did clean it at the grinding place, but just do a quick check. It's coming out clean. That's a good sign. I'm getting a little bit of dirt out of here, but not much. I think they did a pretty good job cleaning it. Stuff's extra thick in this cold weather. Oh boy. Hold on. Let me reposition that. Easy. Easy. Okay. Where are the thrust bearings? Where did I put them? Oh. So we want notches toward crank. Notch toward crank. Re-cleaned all this stuff again. There we go. This is number one. Okay, so we got to lube these main bolts. And I probably should have put these in with because they're going to be out of alignment. Those are in. Okay, it rotates. That's a good sign. So I want to make sure I get like the thrust surface on the crank nice and lubed up. Let me get outside and inside surface here going. Okay. These in. Okay, notches out. There we go. All right, manual says these go to 80 to 87 foot-pounds, kind of a wide range. You're supposed to do half torque first round for everything, and then the full torque. So we got this set to like 40, 42 foot-pounds. Threads are all lubricated. Okay, second round we're doing 85 pounds. You gonna click or what's going on here? 5 now, there we go. There we go. All right, check end play here. Okay, so we'll do all the way forward here, the pry bar. It's just, that's 8 under. And so it's about 7.5 thou, I would say, right? So that's crankshaft end play 4TNE is 4.3 to 8.3 thou. So we're perfect. Just under the max. Off camera, I measured all these pistons and both for weight and dimensions. The dimensions were all right on, but this piston was like 4-5 grams light compared to the other ones. And this is the heaviest rod, so I'm gonna match those up. I mean, it doesn't really matter. We're talking a couple grams here and there. The weight on everything else was pretty good, so we won't worry about that. I was really looking closely into these holes on the rod on the new bushings, and I'm seeing there's junk in some of them, metal shavings, probably just from when he pressed them in. So making sure this is all cleaned out before we get going. Make sure that's in there all the way, which is not. There we go. Not something you want to come out after the engine's built. Wonder if this has to do with the fact that it's about 30 degrees in here. There we go. Okay, so these get put on backwards depending if it's a 4TNV or a 4TNE, direct or indirect injection engine. So we got a 4TNE. This marking is supposed to go towards the flywheel, and then this punch mark right here is supposed to go on the fuel injection pump side. So it goes in like this, I believe. So back, front. Easy. There we go. Okay, so it's saying these match marks. We really want to make sure these are in here all the way. First ring. Where's the little... Okay. And then we'll get this 180 out from that joint. There we go. Jeez. Man, it feels like there's a huge... That doesn't seem right. I didn't ever test fit this. The second ring seems fine, but this first ring is really loose in here. Okay, well, according to the spec, this is okay. It says that the ring groove is supposed to be 2.04 to 2.06 millimeters, and the ring width is supposed to be 194 to 1.96 millimeters. Typical clearance is around 0.1 with a max of being 0.12 millimeters. So this is a 0.1 gauge, and it's really dragging. It's right at 0.1 as a clearance, so that should be fine. The second ring is a little bit tighter by a little bit, but second ring has pretty much the same spec as for side clearance. So we're good. It just kind of felt weird. It felt a little loose, but apparently that's expected. Just set up my piston heater. It should help a little bit. There we go, much better. All right, before it gets standard. There we go. Much easier with a warmer. That's the way it should feel. So I guess it's just the cold weather here. All right, this is the last piston. I just got the pin in, and then I noticed that this circlip, I don't think I did this. I think it got damaged during the shipping process. I mean, you could probably bend it back. I don't really want to reuse it though. So I'm gonna have to order another one of these, and just whatever, don't let me forget about actually installing it. It's gonna be a couple day wait for that. Top and top. All right, which one is missing the circlip? This guy, number 3. Looks pretty good. They want you to stagger these 120 apart, and they don't want the top ring to be in line with the wrist pin. So we'll do like that. So we got one here, second one there, oil ring there. That's not on there straight. There we go. It's supposed to go like this. I think that's right. Let's think about that. So I just confirmed the head, the injection port is right here. So this is the right orientation. And by the way, the crankshaft is rotated with the number 1 journal all the way down. How much further do we have to go? Okay. This red lube is really hard to clean up. It's like cleaning up honey. Manual says 40 to 43 foot-pounds, but do it in 2 stages, so we'll start out at 21, I guess. Not a lot of torque holding this thing together. There we go, 42. Make sure she still spins. All right, well, that's a lot better than it was when I took it apart. There we go. Whoa. This is cap number 4, right? Yep. Getting harder. Ooh, it's getting hard. Still waiting for that one circlip on cylinder 3, but I just went through and retorqued all this stuff, so. Okay, well, let's see if I measured the old ring right. Basically, I just measured the thickness, which was 1.2 millimeter, and the bore diameter was 30 millimeter. Then after that, there wasn't really many rings to choose from. I think that should work. Reposition that though. That fits in there, so I think we're good. That feels right. When I'm underneath, all I'm doing is I'm just putting my hand about right here around the journal just to prevent the rod from hitting it. Okay. This goes, that looks right. Remember there was an O-ring there. It's got to be one of these, huh? Oh, I think that's it. I accidentally bought the wrong size gloves from Harbor Freight, so it's kind of throwing me off here a little bit. Ready for the front cover here, and it kind of looks like there's a couple places where you can get yourself into trouble. First is there's a couple O-rings that you need to put in before this goes on. And the other thing, and I distinctly remember when I took this apart, is there is only 3 bolts that hold this on, and it looks like they're here, here, and here. Since this is held on with RTV, I'm gonna have to find some bolt holes, probably like here and here, in here and put RTV on it, torque it all the way down, let it cure overnight, and then before I can put the front cover on. So I would, in a pinch, I'd probably just use this stuff, Ultra Gray. It works really well for this kind of thing. But I decided to actually use what they recommend. So I got the 3-bond 1212. I couldn't find like a direct analog to Permatex for the 1212. So, you know, it's probably not anything really special, but just one other thing to mention, if you've ever read the directions for RTV, which most people don't, but what you're supposed to do is you put your RTV on and you assemble everything just finger tight. You're supposed to wait like a half hour or an hour, and then you torque it down. And this stuff, you're supposed to immediately assemble and torque it down. You don't wait. It still takes 24 hours to cure. Find our O-ring here. Is this one? Oh, this is going to want to fall off, isn't it? One thing I noticed on this one when I was cleaning this is there was RTV that had gotten squished into here. And this is a really small flange around here, so we're gonna have to go really light with the RTV. Here, I was looking at this video just to see what they had RTV'd from the factory. So they RTV around both of those O-rings in there. They even RTV'd around the dowel pin there. And then it looks like that random bolt there, which you shouldn't have to RTV around that because that's inside the case. They did. Doing some more thought on this here. So when I put the front cover on, all of these bolt holes would be RTV'd because they're on the outside except for these two. So this one, well, this one I think is for the idler gear, goes right there. And I remember there was RTV on here when I first took the front cover off, so that would explain that. And then this one goes on the block. Let me show you on the block. So this hole is right here. So this one's going to need RTV too. It's the worst that could happen. Start up somewhere easy. You know, if you screw this up, you have to pull the cam back out to fix any leaks, so high stakes. Yeah, in retrospect, it would have been a better idea to put it on the case instead of the block. But what are you going to do? Just barely on the dowels there. I guess these are outside ones. And then we'll run some there it is. Should be 18 foot-pounds. Okay, so I think these are the two holes that the O-rings are around, and at least there's nothing, there's no RTV squeezing through them. That's a good sign. Try to avoid getting this on the bushing. There we go. Okay. It's a nice bead going around the whole outside. I kind of panicked when I saw this because the bead goes way underneath, but then I remember this bolt is kind of outside. It doesn't need to be sealed. Some brand new lifters. Easy. Nice looking finish pattern on there. Okay, so the one thing on this engine that didn't need really any work is the camshaft. It was basically perfect, no scratches on it. All the lobes were right in spec, all the journals were right in spec. So all I really did was just hose it down with oil, and it's just been sitting here since, so it wouldn't rust. But I'm gonna go ahead and clean it, and then we can lube it up and put it in. Almost forgot about the cam plug here, but that should probably go in next. Make sure I got the right size. Okay, good. Get it from this way. Oh, did I miss? It's really an awkward angle. I think that's good. It's like not right in the middle, but I think that's good enough. See if we can see in there. Don't really see anything hanging out. That's good. All right, liquid moly. So I found out recently on this stuff, if you run it through your engine and then like pull the oil pan, you might have a mild heart attack because it's going to be coated in gray paste, which you'll think is, you know, bits of your engine, but really it's just this stuff. Once it's done, it just falls down to the oil pan. Rotate this. There we go. All right, well, I just realized I made a big mistake. So I was looking at this exploded view, but if you go back to this one, and I remember taking this plug out thinking I was going to forget about it. This is the front oil galley plug. It goes into the block right there. Let's go look at the block and you'll see what I did. So right in there in that hole, I can get, you see there's threads in there. So this little plug is supposed to go right in there. You could almost get it in if this wasn't right here. But you know, I really have no one to blame for that. That's my bad. So I'm gonna have to pull the cam back out. I'm gonna wait until this stuff cures, and then I think it'll be easy to remove. And I'm just gonna pull the camshaft off. This front plate has to come back off, and then I'm not gonna show this on camera, but I'll clean it all up, and then we'll meet back here once we're right here with that plug installed. And we're back, and the cover's back on. The little plug's in right there. So I'm kind of glad I took it off. One, I was able to kind of just verify that the RTV went on right and it was sealing good. So that makes me feel a little bit better. And you really can't get mad about a mistake like that, because you just imagine the situation where you hadn't caught it and then you're trying to run the engine, there's no oil pressure, and you're trying to figure out what's going on. And that becomes not fun. So I'm happy I caught it where I did, and let's keep going. Anyway, I think it's time to hang the injection pump off of here. So as I mentioned earlier in the video, I did send the pump out to Area Diesel to have them look at it for a few reasons. The first reason is that a skid steer is all hydraulic. I mean, everything runs off of the hydraulic pump, and I believe that is expecting a certain RPM from the engine. So this engine, when I got it, was set for about 2,300 RPM, and after a little bit of digging in the manual for that Cat skid steer, for a Cat 216, they're expecting the the low idle is supposed to be 1,300 RPM, and the high idle is supposed to be 3,240, which is kind of high. Hopefully this engine can handle that without overheating too easily. So I had asked Area Diesel to set the injection pump to run at that for a high idle. Now the second reason, and this is mostly for you the viewer, but this engine was sold to me as a 1,000-hour engine. A lot of people did not believe that. I'm not sure if I believe it. There is a lot of parts on here that don't have a lot of wear. So either it was like overhauled at some point, or it really is a 1,000-hour engine that was just completely destroyed because they ran it with no air filter. The way I see it is the injection pump's a sealed unit. If it's high hour, Area Diesel would be able to tell me right away when they take it apart. And if it's low hour, well, then you can see for yourself what happens when you run an engine with no air filter. So you're probably wondering, then, well, what did Area Diesel tell me? Well, they're actually doing a video of the rebuild process. And at the time of me filming this, I have not seen it. I haven't actually talked to him too much about it. So if you want to find out, I'll put a link up in the video or in the description of this video, and you can go watch it and find out. But for now, let's go ahead and get the pump out. All right. It's the injection pump. We got some swag from them. And what do we got? Oh, this is the injectors. So I also sent the injectors, and they had those cleaned up and tested. So we should be good to go. Something ain't right with how I'm doing this. This goes on here. That's all there is to it. Okay. Did they give me a new nut? Because I don't think I sent the nut that came with it. They put a new O-ring on it for me. That was nice of them. So we're good to go. There's some slotted holes on here where you can kind of clock this thing, but I don't think you really need to worry about it. I think you just do it in the center. It doesn't really matter. So it's nice they painted it, but I think I might paint this engine once it's all assembled. I was considering painting it cat yellow. I have a couple gallons of it over there. That might look cool in the skid steer. I'm not sure. Let me know what you think. They really don't help you much with this bolt in the back. Oh, they put a new key in it too. Well, now I feel bad because they didn't include any of that stuff. They probably needed it to tune it up. All right, so does it go on like this or like that? Oh, it's a tapered shaft, so yeah, big side would go in back, huh? Easy enough. I'm not going to be able to torque this on probably until all the gears are in, so we'll just hold off on that. This is going to be a mess. This will just help with the initial suction. All right. What is this? Ooh, this thing is hard to turn. I think it's just that oil. Actually, it kind of has a hard spot right there. Ooh, that doesn't feel right. It's just when it's torqued down, but let's see. There is a mark on here and here. That's how I had it set up though. I'm just gonna hand tighten it here and see what happens if I... Yeah, right there. It doesn't feel right. Okay, now it feels more even. It's a little bit of a... Right there. I wonder if that's just... It's because it's suction of the oil in there. Let's add a little bit more tightness. Oh yeah, that must have been what it was. I think just that assembly lube was so thick that moving it was kind of binding it up a little bit, because it seems a lot better now. Yeah, that's much better. Okay, let me torque it and try. Yep. That must have been what it is, because it's much nicer now. This goes like that. Then the real question is, does it go like that or like that? This. Okay. So crank needs to move. All right. 8. Here we go. Okay, so we got A and C lined up, because we got to get to B, needs to come back. So if the crank's going this way, it's going this way, so this needs to rotate that way. Oof. Let's see. Okay, it basically needs to go 180 degrees. Okay. That's not going to be enough. Okay, we'll try that. Okay, we're off by 1 tooth. Give me 1 tooth. There it is. Okay, A, B, and C. And just in case you want to see the timing there, those little blue marks. All right, so which way? Yep, it goes like that. It also explains why when I took this apart there was RTV around this, because it's an external bolt. All right, this is supposed to be about 100 foot-pounds. I got the flywheel bolts hooked up on something. This is a tapered shaft, so it might go on quite a bit here. Let's see. Okay, I shoved a GoPro mount in between the crank and idler gear there, just so the idler gear can't move. And then the backlash spec, I just checked 3.5 to 6 thou. So let's see what we got here. So that looks like just under 4 thou. Like, this is not quite. Yeah, it's about 3.8 thou. So I thought it was tight. I thought it was way tighter than that, but when you're dealing with numbers that small, it's always hard to tell. So I think we're good with the injection pump. This is the oil pressure sensor. Standard thread size, so if it's bad, I have a bunch of spare ones laying around here. This is the block drain. So I remember this plug was in there with red Loctite before. I'm just using Permatex 1 for all this stuff. Almost forgot about this guy. I gotta find an oil filter for this thing. Well, it's Matt from the future here, and on a hunch I went and looked in the manual just to double check those marks on the oil rotor, the oil pump rotor, if I put that in right, and sure enough I had it in backwards. Thank goodness I can still pull it out with all the other gears installed. Anyway, here we go. So this punch mark, what makes sense to me is that this punch mark would be on the same side as the one punch mark on here, but they're pretty adamant that the punch mark needs to be facing outward. So that's the correct way. Is there any even difference on this though? I mean, it looks exactly the same on both sides, so it doesn't matter. I'm not convinced. And this is exactly the reason why I didn't put the front cover on yet, because I wanted to go and double check a couple things before I RTV'd this thing back on. Okay, so my machinist gave me these. I think these were the dowels that were in the block here. He couldn't get them out without destroying them. Yeah, they're basically just roll pins. That one end is been beveled down. Okay, so I got these two. These are 1/4 inch, and they match up when you compress them. They're a little bit longer, but I measured the depth here and on the head, and there's plenty of space in there for a longer one. On the head side though, I need to bevel this down a little bit so it goes into the head easier, since this is just a guide pin. Whoops. Final wipe out here. Just collects dirt. There's a lot of sharp edges on here that want to grab onto this cloth and shred it. This still has all that soap residue on it from the washer. All right, now for the It's always a question, which way does it go? Well, the holes kind of line up there. Oh yeah, that looks right. Other way. Yeah, that's definitely wrong. Inside the little pre-combustion chambers here are these little pegs, which I forgot to remove when I set the head in originally. I do see I have new ones here that came with the rebuild kit, but they're a little bit differently sized. Let me get one out here. You can see there's a little bit of difference. The injector hole is bigger on here, and then this. There are these washers in here though, so maybe there's supposed to be a washer behind it. So if we look at the injector, let's see if this matters. So I believe it sits like that. Oh, that should be fine. I don't think this tip size should matter. Let's try putting one in. I already obviously took one out. Let's try putting one in and seeing what happens. So the one I knocked out, there's a little ring there. Really should have done this before I sent the head in. All right, see if I can find a new one of these in the rebuild kit. Okay, well, nothing in this rebuild kit comes close to this. Well, there's a couple that are close, like this one, but it's just, this is not gonna fit. This old one does fit around here, but you'd have to be a crazy person to reuse an old one at this point. So, unfortunately, this is a non-metric, so there's nothing there that fits. Well, it's too bad, but you know, it's my own fault for not removing these before. I think I should still be able to get the head in and just install these later, but let me clean these out. They have a little bit of soot in them. Oh. Oh, they gotta make it so heavy. Oh yeah, those pins fit in great. So I did check these bolts for stretch, and they were all good. I mean, we're only torquing them to whatever it is, 80 foot-pounds or 90 foot-pounds. All you have to do is you just take calipers and you go all the way down, and it should be pretty well controlled all the way down, and then on the threads too. These are all the same length, and they don't go through any water jackets or anything, so you don't have to put thread sealer on them. So just going to put a little oil on the seating surface. So they want 76 to 83 foot-pounds. So I'll just do 80 foot-pounds, keep it simple. And they want to do it in 2 steps, half torque and then full torque. So very simple, just to do 40, 80. Okay, now for 80. Trying to remember how this went on here. I think this screw went in that hole. Did it go on like that or like that? Each one of these rockers has a stamp on the bottom, and each one has a different stamp on it. I don't know if it's a fitting thing. Let me show you a few. You can see it. So it has like the theta. This one says theta K1, K2, KK. They all have something different. And I just, on my phone here, and kind of marked which one was which. So this is pretty simple. And then I also have on here that I marked as this is the one of these that has a screw on it. The rest of these don't. And let's put a little bit more oil on here. spring. And I believe the assembly for the direct injection engine is a little bit more complicated. There's like washers or something you gotta set up right. There's a KI and a K1, but they're stamped differently. It's hard to tell. There we go. See, the tips of all these intake valves are black because they're new valves. This. Wait a second. Yeah, there's an oil hole right there, but all of the bottoms of these are all the same, so I don't think it matters which one I put where on here. Okay, so we'll adjust the valve clearance here. So we'll start with cylinder 1. It's supposed to be 0.15 to 0.25 millimeter. I'm going to do 0.2. And number 1 is the valves are closed. It's supposed to be done when it's cold. It's kind of hard to tell how much drag there is with this red lube on here. Kind of throws you off a little bit. I think everything's looking pretty good. Okay, so for this valve cover, there's a little bit of a mystery here. I noticed this was inside of this, and the parts diagram calls it a baffle. There's like 2 screw holes here, and it was RTV'd in. I seem to remember RTV all around this, which doesn't make a ton of sense because there's like holes in the middle, and I don't see what that would do. There's this plug right here, which is plugged, and then there's a hole here. So I'm wondering if maybe this is for some other kind of, maybe like an oil return or something that comes through there. There is a hole here, but this doesn't do anything. It doesn't line up with anything. As far as like, I mean, there's a hole right here in the block for that, but it's a blind hole. There's nothing there. There's nothing in there. Some other option on the engine, maybe for a turbo or something. I don't know. But I'm not going to RTV this. I'm just going to screw this back. And I see no reason to RTV it. Let's put some of this on to help it stick. We'll let this tack up for a little bit. Is that right? See, I think the studs were on the top originally. Now the exhaust was originally like this, but I'm going to be flipping it around because it'll match up with the stock exhaust on the skid steer. It's going to be a lot of fun getting this started with the exhaust outlet blowing right in my face. Metal gasket. There was a dipstick holder. Was it here? Maybe it was here. The manual gives you general torque specs for all this stuff, but it says, which makes sense, when you're torquing into aluminum, that you go, I think it was like, you take 30% off the value. Let me double check that real quick, but it's, yeah, it says use 80% of the value. So we'll do about 15 foot-pounds instead of what I've been doing. I was able to find some new sealing washers. 14 by 18 millimeter, kind of an oddball size. Also did not have them at McMaster, but I got lucky on Amazon. They just randomly had them there. Hopefully these those center up pretty nice. I was kind of worried how these would fit since the ridge on these isn't as big as the old ones. This washer is going to want to come off though. Just put a little bit of grease on here to help it stick. We'll just do these by feel. That's probably good. All right, I'm not going to screw these in yet. I'm just going to get them started because I'll be pulling these back out, but I don't want anything to get in the cylinder. And I did test these. They're all good. I seem to remember like the bleed down goes right there before the hoses come on. I guess it's like that. Yep, it's just that. These probably don't need to be super tight. What are the chances this hose is still good? I'll have to get another sealing ring for it though. Actually, we're gonna have to bleed this, right? So let's just leave these loose. All right, there's a little tiny O-ring that goes in here to seal the dipstick. Let's see if we can get it in there. I think I got it. There we go. So, what's on here? For the fuel filter, this is the original one. And I think this element just comes off and you can replace this. I noticed like the fittings on here, well, that one that just fell out, They weren't really attached. Like whatever epoxy they had used had failed. And these things are pretty cheap, so I just bought a new one. So like 20 bucks, or it was like 20 or 30 bucks for a new one with like the whole thing. So why not? It looks like they used maybe hot glue or something to hold this fitting in. But I'm sure that'll be okay. Not a big fan of hose clamps, but I don't have any of the other kind around right now. Pretty sure this is the inlet. This could really use like a anti-rub protection on it. Easy. Oops. Okay. Now there's a bunch of different size bolts on this front cover, which is pretty common. So I have marked kind of which ones go where. So I know, for instance, this goes here. This one went here. There we go. You see that line of RTV around the inside. That's why I'm very nervous about doing this. Just got to make sure you don't use too much. Okay. So these bolts here are all torquing into aluminum, so they're going to be 15. And then everything else is going to be 18. So I'll do 15 first, and then I'll go through on the outside ones and do 18. It shouldn't really matter. There's not probably really a order that needs to happen, so just kind of, oof. I don't like that at all. I think that one's stretching. Yeah, that one does not feel good. Yeah, that's just not long enough. There's like only 3 threads of engagement right there. Now we're gonna do 19 foot-pounds for everything that's going into the block. Okay, well I just checked the parts manual and I did in fact screw up. All of these longer bolts, I thought they were all the same, but there was one that was M10 by 75 instead of M10 by 70, which is what this is. So I must have put the 75 in one of these other holes, which it didn't have a problem. It didn't bottom out or anything. But I'm gonna have to, this bolt's no good since I already messed up those threads trying to torque it. So I'm gonna have to go get another M10 by 75 to put in there. All right. Now remember, this was not easy to get off. Oh, what's going on though? Okay. On here originally was this O-ring, which is toasted. There was no replacement O-ring in the kit. There we go. Felt like it was getting, there we go. Felt like it was getting easy there for a sec. I'm gonna wipe this off because this is where the oil pan's gonna be. Don't want it to interfere. All right, up next is the water pump. So this is the original one. It's cast aluminum. Still has some bolts stuck in it. Here's the new one. It's cast iron. This is not a Maxiforce pump. They were out of stock when I was ordering from Area Diesel, and they had, I could get an OEM one for like $400, but this is like a $100 Chinese one. And I just noticed this. This is very concerning. This is where the hose goes, and it's not a finished surface. It's still rough cast. I've never seen that before, and I'm assuming that's going to be a problem. I don't think anything's going to want to seal on that. So this is a pretty good example of why you don't want to just order a bunch of random stuff off of eBay, even if the part number is correct. It's always nice to go through like an actual distributor that can kind of guarantee what kind of quality you're going to be getting. These bolts. Thermostat. There's a spider in there. It's almost there. I think that's it for this thing. And what's this hole right here? I wonder if that's like a weep hole for the, it leaks through the seal or something. The other pump has the same spot, but it's plugged. Also, this is like a cast iron impeller. Check this out. You can see the rough, you can probably just barely see the rough surface finish because it's, I've never seen this. I don't know. I don't think I can put this on the engine, guys. We might have to hold off on this for a little bit and find a better one. It's like someone saw a picture of a water pump and tried to make one. So normally I would have put the oil pan on by now, but I can't because the outside bolts go onto the flywheel housing. So it's gonna have to be done while this is off the stand. But before I do that, I wanna put a drain right here. You actually can buy a pan for this engine with a side drain, but I can just drill one in right here with a bulkhead fitting. So I did happen to have some dash 12 AN stuff here. And I had some braided hose too for it. I think this is dash 12. So I went and bought a bulkhead fitting. Originally there was like a brass valve right next to the oil pan, and you would turn that and then it would come out the drain hose, but I have like a plug here. So I think I can just, you know, I mean, I guess assuming there's no hole in this hose, that might be a little bit of a danger. This is pretty tough though. Okay. So we're going to want this to ride right on the bottom. And we need a 1 1/16 drill bit. I think I measured this, it was 1.05 inches. Pretty good. Well, if you've never used one of these drills before, they're really prone to snapping off right here, but this metal's so thin, I think we can get away with using one. Otherwise, we'd have to use a hole saw, and those are never as accurate. This is going to want to snap off in my hand. Ooh. think that should work. How much space do we have on the inside? Yeah, I think that's about as low as you could go without it being a problem. And then yeah, we're quite high off of the bottom, but oh man, that is really high. Actually, I think it's going to be okay because the bottom of the drain is below like the distance between here and here, which if this little area has some oil in it, that's probably fine. I mean, it's the same thing with this. This is raised off quite a bit. I'm doing this over here where there's not metal shavings everywhere. Uh-oh. Just kind of, we'll just guess on that. That's probably good. Okay, so off camera here, I got this kind of mocked up to figure out how I'm going to mount this bell housing to the run stand. Now this run stand was already modified when I had to mount the Isuzu engine to it, which had one flywheel housing size up. So I had this is welded down here, and then this is just bolted through to the bell housing, and I just flipped it 90 so I could drill different holes. Anyway, it's all hooked up. All right, well, the rear main seal is actually in here. Let's hit this out. The dirt daubers really went to town on all these holes. I already cleaned out the four for the mounting, but these all need to be cleared out because the plate for the pump goes on here. Yeah, now that's what was in there. All right, those are done. And I'm probably gonna have to use these mounting holes. This. Well, I think this is finally ready to come off the engine stand. Almost forgot about these. Actually, before I do that, the engine needs to mount to these things. And here are the front mounts. They look like that, which I measured them. They're really close to a small block Chevy engine mount, which I have some mounts around here. Let me find them real quick. Yeah, I mean, really just need 2 bolts in. It looks like just a couple small adjustments with the torch here, and they should bolt right up. Barely even until I modified it. It's good enough for what we're doing. Put a chain here to stop it from rolling. Ooh, if I was smart, I'd get my load leveler out. It's already too late. No going back. It's always the scary part. Okay, got the new rear main, and yeah, we got to work on the floor here for a couple minutes. But just looking at this, it looks like a little nicer one than the original. You got this felt right here to keep dirt out, and then the seal placement is a little bit different. It's more inset on this new one than the old one. Hopefully the new sealing edge will ride on a virgin spot on the crank instead of that old original groove. I guess we'll find out. I'm obviously being very careful with this stuff, not getting it in the seal, but it does kind of help stick it in there. Oh, I'm really glad I put sealant on it because it's not very tight. We pre-lube this real quick for the seal. There's dowels on here. Oh boy. It's really hard to see what's going on. Ooh, I think I got it. There we go. So only torquing these to 40 foot-pounds. Should be pretty easy to do hanging here. Now this is not the original flywheel that came on this engine. I bought this one off eBay because it is properly set up for the to hook up to the pump. Or the other one had some other weird connection on it. It's nice everything's so small and light on here. Some of these aren't in. All right, so the manual says torque these down to 95 to 110 foot-pounds, which is really getting hard to do because I can't easily stop the engine with the crank bolt up front. But I was looking at my DeWalt manual here for my impact, and if you put it in #1 mode, it says the tool operates at a maximum torque output of 100 foot-pounds. So that's what I'm going to do. I'm just going to run this at 1, and we're just going to do it like that. This is the part where being too lazy to not get the load leveler set up is going to come into play. All right, well, it's on. It wasn't too bad. It's on nice and secure. So you can see on the back, there's just 4 bolts here on the bell housing, and they just go through this square tubing. The bottom square tube's welded, and then the top one's free. Just makes it a little bit easier to assemble onto here. But it's on there really good. So unless the bell housing cracks, I should be good. Let's see if I got the right size oil filter. This O-ring is a little bit bigger than the old O-ring, but I think this should work. It's just going to be on a different spot. By the way, I just want to quickly point out, I didn't forget this one bolt. I did get a replacement bolt that was the right length, and it torqued in okay. This is just mostly to hold the gasket in place since we're putting it on upside down. Okay, well I already got the flange cleaned off here all the way around, but I just need to put a little bit of RTV on this transition spot between the engine block, and this would be the flywheel cover. And then up front between the block and the front timing cover. Gonna wipe this in a little bit, just a little bit, is all you need. Can't see anything. These bolts are like so short, I can't get my fat fingers in there. Well, on the Perkins engine, the drain was about right here, and it was a 90-degree fitting going straight forward, and then this was the hose on it. So I just want to get an idea of what I need to do here for my own drain hose. It'd be nice to have like a little bracket or something right here to hold it in place. This will go here. This actually might be an okay length. And I'm just going to cut in between with the chop saw. It's been a while since I've made one of these. So bear with me here. So it's coming back to me. So this goes in here. You got to take the tape off here. This is the side they taped, and it's pretty messy. You know, let me clean that up a little bit. So there is some stainless steel weave in there, but a lot of that's just fabric. Although making it look nice might be hard. Hit the camera stick. It's in all the way up to there. Doesn't look great here, but you know, it is what it is. It's up there all the way. Now, I used to have a wrench for this, but let me see if I can find it. A special aluminum wrench so it doesn't mar it all up. Pretty sure I have one. Let me check. I couldn't find it. I think that's far enough. All right. That was pretty easy. It's nice that it swivels on here. I think there's like an O-ring inside of there to seal it. That's convenient. See how long that lasts. Put a gallon or so in. If that drain hose or the bulkhead fitting I put in leak, we're in for a bad time. Well, nothing in there yet. No leaks yet. Okay, we're getting actually pretty close on the dipstick there. This is just the Lucas break-in. I think they're all pretty much the same. Now really this is mostly just for the new lifters with the cam. but it won't hurt anything else. Is there an O-ring that's supposed to go around that? Kind of looks like it, doesn't it? Let's see. So what am I missing? I'm still missing the water pump. It should be here in a day. And then that front O-ring for the crank bolt. Looks like my McMaster order got delayed by UPS. Okay, I got the starter wired in, the battery, and only the oil pressure gauge is wired in right now. So let's just spin it over, take the glow plugs out so there's no compression, and we'll just spin it over for a minute and see if we get any oil pressure. Probably pull this out. That is really loud. All right, take two. I just kind of fix some wiring up a little bit. Yep. Got oil pressure a little bit. All right. I don't think 150 was right. This is the return. All right. There's probably going to be a lot of pumping for this. Let's push an air out. That's a good sign. I remember reading there's a bleeder screw on here. I think you're supposed to do that first. There we go. There's a lot of air in there. By the way, while we're looking at it off camera, I did put some hose protection on this fuel line that runs up to the injection pump. And then I replaced the hose clamps with the correct type here so they won't rattle off. These are all cracked loose. I never tightened these originally. So we are going to now spin the engine over and see if we can get some fuel into here. I don't know. So there's a solenoid cutoff back here. And I don't know if you're supposed to put, you know, if it's running by default or you put 12 volts on it to kill it. There's also this. I don't know what this is. I'll have to look that up eventually. I'm pretty sure this is the cutoff right here because it's right at the end. Anyway, we'll just try to run it as is and see if any fuel comes out. It's saying 150 psi on the oil pressure. I don't think that's... I think we might need to swap that out. Anyway, nothing's coming out here. The shutoff is closed by default. Let's see if this... Yeah, I can hear that click on. So that needs to be on. Still no word on what this is for. Didn't see it in the manual. Anything yet? Oop, got something. I'm gonna close these up a little bit so they don't spray me in the face. Okay, I think that's good. So the oil pressure is still reading 150 psi, so let's, I guess, go ahead and put the other sensor in here. Ooh. This is a BSP fitting, just like the other engine that we did recently. So I have a bunch of adapters for it. All right, let's try again, see if we get better oil pressure. It's still 150. I'm gonna take this off and see if I can see oil coming into the all the valve stuff, because I mean, there could be a few things going on. It could just be that the assembly lube is you know, creating a lot of pressure. It could be something stuck somewhere. I think it's, well, it should come out of all of these. It does look like it's been oiling up here. Let's see. Yeah, I think it's. Yeah, it's shooting oil out of all of these rockers. So, okay, I need to, there's like dust falling down from the roof. So this is good. We got all the oil all the way up here. It should be like, I would think it would be around 80 is what it should be with cold oil. Well, this is indirect injection, so it's probably not going to start without a little bit of heat from the glow plugs here. I guess we're just going to have to fire it off and see what happens with the oil pressure and kill it if it doesn't go down. I mean, hopefully it's not something like the bypass being bad or blocked up. I mean, I guess I should have checked it before I installed it, but at least I eliminated the sending unit is the problem. This. And then we just need 12 volts to here. We're gonna have to get Charlie out of here. It's gonna be probably pretty loud with that upturned exhaust in this area. Let's give it a little bit of glow plug here for a minute. Okay, and this goes to solenoid. Here we go. Give it a little bit of throttle there, I guess. More glow plug. It's a little bit chilly in here. All right, new battery. Let's the glow plugs again. And here we go. All right, well, it went down a little bit. It's also running like it's got some fuel not running. All right, well, there is a leak right there on the ground, and it's coming from the oil filter. And that thing is on there fairly tight, so that's kind of a sign we have a high oil pressure problem. Oh yeah, I think it blew that out. I can see it right on the top there. So that's why that's leaking. I think the safest thing to do next is to pull the front cover back off. I mean, it's really easy, just the front cover. I have to deal with the RTV again and then figure out what's going on with that bypass. Well, this is what happens when you don't test and measure everything that goes on your engine before putting it in. Oh, I hate RTV. No No RTV in the engine though, that's good. Well, this run stand's paying for itself because it would not be fun doing this in the machine. Oh. Oh man. Yeah. It's jammed. Well, it's a lot of pressure to push in. That does not feel right. Let me show you the old one so you can see. Easily moves. And on this one, it is just barely moving. It's like twice the pressure, if maybe more. The non-metric size nut on here. Spring. Ooh, we got a washer, several washers. Okay. That's it. The bore in there looks pretty good. This is just pretty stiff spring. Now are these just must be for length to shim it. It's like a similar spring. So new pump stuff this side, old pump stuff this side. These springs are exactly the same. The thickness on the coils is the same. The diameter is the same. These are the same. So really it's just a difference is these 3 random washers they threw in there. These aren't shims. These are just random washers. Like you can see they're rounded on that side and then flat on the other one. Like they've been just punched out. So I don't know what's going on. I looked in the manual. There's nothing in the manual about servicing this at all, but it's clearly been put together wrong. So I don't know if this was someone at the factory just having a bad day and wanting to take it out on someone or what, but I'll just reassemble it without these washers. So this might seem a little crazy, but I feel like post-COVID, like parts just are out of control as far as QA. Just nothing's working anymore. So this is really my fault. Even though it's put together wrong, this is my fault because I didn't check it. I didn't do any inspection on this bypass. I just figured it would be good. The least I could have done is just compared it to the old one. So let's give that, how does that feel? Man, that still feels hard though. Okay, so just doing a rough comparison of pushing on these 2 plungers after taking these shims out, still did not feel right. And I started just swapping one part back and forth, and I finally, I think it's related to this end cap. And let me show you. I got a depth micrometer here. So this one, I have it set to this, so it's perfectly to the depth of that. But look at this one. This is the new one. It's way more shallow. And the depth of this sets the preload of the spring, right? Because the more shallow it is, the more it's pre-compressing the spring. So that's one issue. And I think that what they did, which is crazy, is they shimmed it the wrong way. Because look, that distance right there is approximately the thickness of these 3. Well, it's thicker, not as thick. Well, it's about as thick as 2 of these shims. So it's like they saw that and then they shimmed it the wrong way. They actually increased the preload with these shims versus decreasing it. So that's crazy. I'm not sure what happened here. There's no way like an engineer would tell them to do something like this to fix it. It's almost like they got a bad lot of these in and they just, someone on the assembly line figured, oh, you just shim it up to compensate. But there's no way that would work. So this, like I said, this is one of the weirdest things I've come across. I haven't seen something like this before where it's just this screwed up. But anyway, I think it's easily fixable. So I'll just use this other end cap from the old pump, no shims, and then the spring, these springs are pretty much the same. They go around every bolt hole. All right. Right there. Well, it's been a few hours. I think the RTV is probably set up enough to test this. Fuel solenoid is off. Battery is charged. There we go. That seems a lot better. So I saw 40. So before we continue here, let's maybe just try starting it real quick and see if it sounds a little bit better. All right. Got a little bit of a smoke issue in here. I should open that door a bit more. Okay, just got the new water pump in. This is a Maxiforce pump. You can already tell it's made out of aluminum instead of cast iron. So this stuff. So yeah, this is a lot closer to the original. Let's look in there. Is there a cast? The impeller is just like the other one. Looks like a stainless steel impeller. This is nice smooth aluminum. This weighs about 40 pounds less than the other one. And there's no, I don't have to deal with those things. Okay, so. Oh, this has to come back off. Like that. I must have had that strap point on the wrong spot. Oh yeah, it goes over here. No wonder. I was wondering why it was going behind the water pump gasket. It goes right here. Makes a lot more sense, actually. And I just realized I forgot this thing. So this needs to come back off. Push that in. There we go. So on the original pump, we got a 4-bolt thermostat housing, but it looks like they were doing that. So just using 2 bolts. Okay, so there was a gasket here. Thermostat. I did test this thermostat, by the way. Like this, right? There it is. Right. This one's supposed to be tapered. It's going in pretty far though. And it's aluminum housing. Maybe we should just do that and see what happens. So this one's straight thread and I just put a new O-ring on it. So this is the temp sensor for the run stand, and it actually is already adapted in here for the from the Isuzu engine. So it just fits right in. Now you got to start thinking about the alternator too, since this didn't come with an alternator on it. But there was an alternator on the Perkins. As long as this fits through here. It doesn't. Is that threaded? Does it fit here? Oh, nice. Okay, so if that goes through there. Ooh, that pulley's way off. Oh, change this spacer. figure all this stuff pretty much uses the same parts, all these old engines. Just need a few adjustments, you know, add some shims here and there. I think this will work fine. Nice and solid. I'm gonna have to change this hardware out because this is like Perkins bolts and they use like 13mm and other random sizes. And it's always hard to tell, especially on camera, but it is lined up there really well. I just need to get a belt for it, but that worked out pretty nice. Plus, it says Caterpillar on the side. Super fancy. It's gonna have to be a long one. Oh yeah, 2 more. You want a good, you know, 2 inches of deflection there when you're using zip ties. That does look pretty lined up there though. Pretty happy about that. Radiator hoses are hooked up. I think they might work. I did have to kind of reposition the radiator here. It looks a little bit janky, but it's actually secure on here. I just had to do a few adjustments here, but it's all kind of zip tied together so it shouldn't fall apart or rattle off here. Really, I just don't want it vibrating against this because it'll wear a hole in the aluminum. And yeah, this looks good. All right, well, we're about to be in direct sunlight, which is not ideal for filming, but I think we're ready to go here. There's water in the tank. We got a fan on standby. So let's get going. A little cold out here this morning. It's about 40 degrees, so let the glow plugs heat up. I think the thing I'm most worried about is this plug leaking since it didn't seat in there very well. All right. All right, got good oil pressure. I think the fuel lines, this isn't very full, and I think it's not sucking fuel because I kind of moved it around and it was running better. There we go. That sounds a lot better. Much better. Still having trouble. Added a bunch more fuel to the can. See if that helps. It's kind of acting like it was not getting enough. Go. Much better. Look how smooth that is. It helps to, I guess it helps to have fuel in it. Makes it run a lot better with it. Nice. Good oil pressure. if it's not that loud. Uh-oh. They're sneaking right there. Not good. All right, I'm gonna fix this plug now before the water gets really hot. It was starting to heat up. I don't know if that's gonna work. It's really loose on there. Might have to get like epoxy or something. Oil pressure's dropping finally, warming up a little bit. fan belt broke. Did not see that coming. Actually put up a pretty good fight there. It lasted about 15-20 minutes. But I'd like to, now that the thermostat's finally opened, I'd like to see it actually regulate itself. Really? I need one more? Let me adjust that fan belt just a little bit. Yeah, it's going back down. Okay, well, let's check it out for leaks now. There's really not much to leak on here when you get down to it. You know, oil pan looks good. That block plug, and then all these front covers that are RTV aren't leaking. No bolts on the front are leaking. I don't know if daylight's the best way to do this, but this plug didn't actually end up leaking. I thought it would with that tape on it, but I'll probably still take that out and epoxy it in there just so it's more of a permanent fix. There's really no need to, I don't really need it for anything. Let me flip this engine around so we can look at the other side in the sun. So this side was good. No leaking. If the rear main was leaking, you would see like fluid right here, which you don't. And then I already stuck my head kind of up in this area here, and there's no leaks coming out of the oil pan or anything. This isn't leaking. And this is the same filter where the seal blew out. I just kind of shoved it back in there, but it's not leaking. Nothing coming down the block or from the head. The only thing I saw that was leaking, and I still see it actually, is this little plastic fitting. So I'll have to pull that and figure out what's going on with that. But everything else seems, I didn't see anything. But yeah, this thing was running really smooth. I mean, right at the beginning, it was kind of scaring me because it sounded like it was missing, but that was just a fuel delivery issue where the hose in the fuel tank was curled around and sucking air. So once I fixed that, it was really smooth. And yeah, pretty happy with it. And big thanks again to Area Diesel Service for tuning up that injection pump. It was running really nice. The one thing I didn't do is check the RPMs to see, I mean, the idle sounded right. That was a really nice sounding idle. But it was screaming at this RPM. You heard it there at the end. I'm assuming that's right. I'll have to check that later. Make sure it's correct. I mean, it could be. I think, what was it supposed to be, 3,200 RPM or something, which is a lot. Anyway, yeah, I think we can call this one a success. Now, at the beginning of the video, I promised you guys some more information about this engine as far as getting money back from it, because it was sold to me as a good running engine, which it obviously wasn't. It required a complete rebuild and a lot of machining. So what happened is, after I took the engine apart at the end of last video, I went and took it to my machine shop and got a quote for the machining. And then I contacted Area Diesel and got a quote for the parts. And the total cost for that was about $3,300. It was $3,329. So at that point, I contacted the seller on eBay, who has really good feedback on eBay, and I let him know that's how much it was, and he refunded it. He just sent the money right back to me. Now, I know a lot of people were wondering if the seller was a scammer or they were just lying about the engine. So I asked them a little bit more about how they got this engine and why they thought it was a good running engine. And it turns out they were just reselling it from another location that had the engine, and it was a trusted location that told him it was a good running engine, so that's how he listed it. And I think that's kind of a typical thing for parts and engines, the used market. That's kind of how it works. So I don't think he was actually being malicious. I mean, the fact that he paid me back kind of proves that. I didn't have to threaten and say I was going to put him on blast or something on YouTube, and he just did it because he knew it was the right thing to do. So he actually ended up taking a big time haircut on this engine, unfortunately for him, but it's just the way it goes sometimes in that business. Now, a lot of people were wondering why I didn't just return the engine as soon as I saw it had no compression, and that is an option. I mean, it's a little bit different situation for me since I'm going to do this on YouTube. Obviously, taking the engine apart, rebuilding it, and then that's going to bring content, and I'll earn some advertising dollars from that. Now, if I wasn't doing this for YouTube, would I have returned this engine and bought a different one? I don't think I would have, because buying a used engine is always a game of Russian roulette. I mean, there's just so many sketchy places out there selling engines, and this is a good example, right? So if you have the opportunity where you put a little bit of time in and you maybe gain some knowledge and the same amount of money, I mean, I got all the money back that I wasted on this one from the refund. That's a great opportunity. I mean, now I have an engine that I know is good. I know what parts are in it. I know who worked on it. And I feel a lot more confident in it. So I think that's worth it, at least for me. Maybe not for you though. Anyways, that's gonna do it for this video. If you made it this far, I know this is gonna be a really long video. If you made it this far, thanks for watching. So in the next video, and you probably already know this, we're gonna try to get this engine stuffed into that skid steer. It should be a little bit of a challenge, but doing an engine swap is always kind of fun. And I think I've set it up where it shouldn't be too painful. We'll see. Anyway, I'll catch you for that one. Thanks for watching, guys.